Hello, I'm Sam McDonald, one of the senior consultants here at One Spatial Australia, and I'm here to discuss building your no-code web application using FME Flow, or as I'm alternatively referring to it as, how I learned to form a flow as a self-service portal. Now, before I jump into some of the more technical details, I first wanted to talk about FME's key selling points, which I have shamelessly taken straight from Safe Software's website. Now, bear with me, as this will be a little salesy, and I promise I'll put on my best salesperson voice, but I do have a nugget of a point to make in all of this. So, let's look at the first one. Build a more efficient organization. If you can imagine the solution, the FME platform gives you the power to make it happen, from bulk data movement, ETL, or extract, transform, and load, to quality assurance, to data replication, and more. Build with no code. Accomplish more and do it faster with our no-code interface. Build for data variety. Whatever type of data you have, FME can handle it. Build for delivery. Support for batch processing, ETL, event-driven data, and high-speed stream data all within one platform. Build for the future. FME is backed by Safe Software and its vast community of users, expanding its reach every day. The second one to cover is automate for growth. FME gets your data working for you by integrating all of your organization's applications and data sources. Automate workflows. Save time by streamlining data flows with event or time-based automation. Automation without code. Extensive automation and no-code experience makes it easy to create and schedule custom processes. Automate tasks. Handle large-scale data-driven processing and integration. Automation data sharing. Easily build no-code corporate web applications for data sharing, updates, or scheduling. And finally, automate quality assurance. Build QA workflows that flag and fix data quality issues at the source. Now, the simple reason I'm talking about these is this. One of the most recurring points in all of this is the fact that it is no code. It is codeless, that you do not need to know how to code. I'm someone who personally loves coding, and I have a myriad of coding experience, but at the same time, I'm able to reflect on the time and money that has been spent for me to get to that point. FME makes the ease of access dramatically easier than coding alternatives. And to be fully candid, I do so much in FME when I could be doing an equivalent in Python or such, simply because it is quicker and easier to use FME for it. The next thing that I want to discuss is the relationship between FME Form and FME Flow. Though FME Flow is where our codeless web applications exist, it is important to understand how both Form and Flow come into the picture when going from nothing to a FME-based web application. FME Form is the build of this equation, being the developer tool where you can form your codeless workflows to convert your formats, transform your data, integrate your disparate data sets, and validate everything at the same time. In our training, I typically like to use this sentiment. It is designed to take what you have and transform it into what you want easily. FME Flow is the automate here, being a web enterprise platform that workflows that have been built in FME Form can be published to allow them to be uplifted by out-of-the-box functionality relating to scheduling, event-driven automations, self-service portals, integration patterns, and user access control. It even comes in two different flavors, where FME Flow can be installed where and how an organization requires, and licensed to meet their needs. Whilst FME Flow Hosted is the SaaS solution that is hosted on Safe's infrastructure with a pay-as-you-go model that only requires a few clicks of a button to get started with. For the purpose of this discussion, Flow and Flow Hosted are entirely interchangeable, as they are the same product, just deployed and managed differently. Having established that both tools are important, let's start with FME Form. To go into a little more detail, FME Form is the visual programming tool where blocks can be dropped, connected, and configured without having to script or code. It is capable of reading and writing to over 450 formats, supporting file-based formats, various database providers, web-based services, and more. chances are your formats of choice will be supported out of the box. It even goes as far as to support things like Minecraft. So if you're a Minecraft fan, you might become an FME fan. You are able to restructure your data with over 500 different transformers, offering various functions. And all of this is through an interactive drag and drop interface that is extremely easy to use. Finally, it gives you tools to visualize and inspect your data at any stage of your workflow, meaning that you can review your inputs, outputs, and even the results from each stage of your transformation, giving you a really good understanding of what each step that you do is actually incurring for your data. It really is an intuitive and easy tool to use, whilst also being very powerful, something that I will be demonstrating later in this talk. Now, when we're talking about FME form with FME flow in mind, an extremely important thing to talk about is parameterization. In the world of FME form, a parameter is effectively any configurable option. These are how authors of workflows configure the workspace, the readers, the writers, the transformers, and more, providing a fine level control to these components once they have been placed. There are many different types of parameters with many different rules that restrict and control what values can be entered. For example, there is the number parameter, which will not permit characters that are not numeric by default, prohibiting alphabetic characters. Additional rules can be applied to control upper and lower limits, the precision of the number, etc. Another example is the file and folder parameter that provides a file or folder selection dialog box. Rules can be set to limit the type of transactions, whether it's read or write, what file extensions will be recognized, and such. Extremely useful for readers and writers. The key reason parameters are so important here is because of user parameters, which are a mechanism for exposing these aforementioned configurations to the users of a workspace, allowing them to specify their own choices when running a translation and not limiting said choices to just the authors who understand the design. When using these workflows on FME Flow, user parameters are the main method of dictating what choices and control we want to allow general users to have, an incredibly important aspect of a self-service portal. Once you have designed your workflow in FME form and given it the appropriate user parameters as I've just discussed, it is likely time to publish it to FME Flow. As FME form and FME Flow serve as a client-server relationship, authors can actually publish directly to FME Flow from the FME form interface. All you need to do so is an account in FME Flow. Once authorized and able to publish, you will find that FME Flow elevates workflows through a number of different functionalities. Through being able to define schedules, such as a simple interval or perhaps cron expressions, through automations that allow us to tie up multiple workspaces and actions together into state machines, through data streaming processes that receive or submit high volumes of data, through event-driven triggers, allowing us to, say, kick off actions in response to particular events, such as detecting a new file in a directory, receiving an email, a new file being dropped in an S3 bucket, and so on. Through easy to set up self-service portals, which will be the focus of my upcoming demonstration, and through access control for users, which allows us to restrict or permit access to workflows based on individuals and their groups. And that can be controlled natively in FME or can actually be tied to your Active Directory. And a quick sort of noteworthy aspect in all of this is that FME Form and FME Flow have the same engine behind the scenes that runs the translations. This means that what works on FME Form should simply work on FME Flow as well, given both have the same access to your data and such. When publishing to FME Flow, part of this elevation of workspaces that I have been mentioning is access to a handful of integrated web services that control how users and applications can either serve FME Flow with data or can be served data by FME Flow. Now, there are a number of these services that include the job submission service that will simply run a workspace as is and will write the output data to the location that is specified by the writers in that workspace. The data download service that will allow users to actually serve themselves with the results of the translation as a downloadable package. The data streaming service that will transmit the results of the translation as a stream that allows other applications to open the results natively. The upload utility, which provides an option for user and applications to upload their own data at runtime when selecting their values for the user parameters of a workspace. And to quickly make mention of it, the REST API service that allows FME Flow to be used as a backend to other applications. For services like job submission, data download, and data streaming, it is very simply just a case of ticking a particular box for each of these, and FME Flow will do the rest for you. No need to change anything, making it very simple. For the upload utility, FME Flow actually automatically provides this whenever you have a user parameter that specifies an input file, typically used for readers. This fact should really further my agenda on the previous slide on the importance of parameterization, something that I will continue to show in the demonstration. Once your workflow is published, you are absolutely able to just have your users log in and navigate FME Flow and run that workspace. That's easy enough. However, FME Flow actually has a bit of functionality that we call workspace apps. And what workspace apps allow us to do is to create custom landing pages for published workflows. And on these custom landing pages, we can actually customize the appearance of the page, have it sort of represent your organization or the context of what the particular workflow is doing. And then additionally, you can optionally require authentication to access this or make it publicly available. As long as you've got the URL, you can access it. Whereas when you want to just run the workspace on FME Flow in a traditional sense, you have to have access to FME Flow. You have to have a user account. And so what these workspace apps really do is that they offer a fantastic option for creating a self-service portal that is tied to a particular workspace, to a particular tool, or whatever you want to call it, that is easy for users to use without needing to understand FME Flow. They don't need to know how to navigate FME Flow. They don't need to know how to log into FME Flow. If you set up the visualization correctly, they don't even to know that it is FME Flow. That's all irrelevant. All they need to know is the URL and how to specify those parameters to get what they want. So at this point, I've talked to you quite a lot about FME Form and FME Flow and the important considerations for both of them when looking to make a codeless web application. But instead of talking to you more and more, I'd actually like to get into this demonstration that I keep mentioning. I really want to put what I've been talking about into practice and show you in real time just how easy it is to actually build these codeless web applications. And so for this demonstration, I'm going to have the following scope. A workflow that allows users to clip satellite imagery to an ad hoc boundary, which will be a boundary drawn on a map by the user, or an uploaded boundary, so being able to upload your own files to determine what the boundary is that you want to clip the satellite imagery to. Now, this sounds hard in theory, but in practice, it's actually quite easy. So let's get into it. So jumping into FME Form now, which you can see on the screen, we're going to get started on this demonstration. And the first thing I'm going to do is read in some GeoTIFF images, which is my satellite imagery. And they're actually of Vancouver, Canada, because that's where Safe Software is based. It's a bit of a nod to them. So if I want to get started, I just need to add a reader. And I've got some GeoTIFFs on my local machine that I'm going to read. Go ahead and get them read in, and bingo. I now have a new block, which is my reader for my GeoTIFFs. And I can in fact even inspect this data already, just to confirm that it is being read in correctly. And there it is. Too easy. So that was step one. Step two is to implement this choice. The choice being if users want to select to write an ad hoc boundary or actually upload a file to define the boundary. And so the first part of that I'm going to do is I'm going to define a choice. And the choice is, do you want to upload a file or define a boundary? Select boundary type is what I'll tell people. And here I'll say to the users, one choice is an ad hoc boundary, and I'm going to return geom to my workspace for that. The second one will be uploaded file, and for this one, I'll return a value of file. These just make it easier to work with. So that's my choice. The next one is the geometry ad hoc boundary. And this is going to be through the geometry parameter. So I'll go ahead and create that. I'll call it geom, and I'll say, we'll leave it as select geometry. That's perfectly fine. For the geometry types, I actually want to remove line and point because these don't make sense for defining a boundary. And I do want to actually specify initial bounds because this will make sure that the map starts on the correct location. So I just want to manually enter these or copy and paste them from my little resource off screen because they are annoying to manually type. This will just make sure that the map starts on Vancouver, just so that people don't start with a global map and have to go find a very specific place in the world. Not very good for the user interactivity there. So that's our initial bounds. All done there. Third one to add is a file folder URL parameter, and this will allow me to specify an input file. So I'm just going to call it file, select, or actually let's say upload. Upload boundary file. And I'm going to read in a file. It is a read, not a write. And we will specify an extension because I specifically have shapefiles for this. So I'll actually say that we can only read in shapefiles. Though you can set this up to read in a collection of different formats. That's not a problem at all. So if I wanted to, I could check that these all are working. And there's all three of my parameters. You can see the choice here. But one thing is that the choice doesn't really affect which one of these users can use. So I can actually update this to make it so that this choice sort of shows or hides particular things. In the geometry one, under conditional visibility, I'll just set the choice is equal to ad hoc boundary. And if that's true, then this is showed as enabled. Same with the upload boundary file. I'll go conditional visibility and say if the choice is the uploaded file, then it's shown as enabled. Go back and have a look. And now we'll see that one's selected versus the other selected as such. They become available versus disabled. Excellent. Click OK. And we have our parameters. The next thing that I want to do is start implementing the logic that will use these parameters and facilitate the clipping of our satellite imagery. And so the first thing that I'm going to do is drop a transformer called a creator, which will basically just create a dummy record for me to work with. And then the second one will be a tester, and this tester will do the test on what state we're in. And that's done very simply by checking the user parameter and asking, is it equal to geom or is it equal to file? And we'll do something according to that. And we can even quickly test to make sure that isn't working by just quickly selecting one of these, so ad hoc boundary, and I'll just give this a dummy value to make sure it's happy. And this should go on the past port. If I were to do the exact same thing and swap it to uploaded file, this will go, I gotta actually upload a file. The other good thing about parameters is that they make you do the right thing. I need to specify a shapefile. And there we go. We're now on the other path. So too easy. Let's go ahead and keep working with that. The next thing that we want to do is we'll start with that ad hoc geometry path. So user specifies their geometry. It's going to come in as a text representation. What I need to do is drop a transformer that will take that text representation and actually turn it into a geometry, which is through a transformer called the geometry replacer. That will be GeoJSON coming from our geom parameter. And that's easy enough. That's all set up. The next thing to do is set the coordinate system for that, which will be a coordinate system setter. You'll find a lot of these names are intuitive. And for my coordinate system setter, this is actually going to be along line 84. And then I'm actually going to reproject this data too, because the coordinate system of our ad hoc boundary is not the same as the coordinate system of our satellite imagery, and I want to make the two align. So I'm going to take this and reproject it to a universal traverse Mercator 83 zone 10, which is for Vancouver. So that there is our ad hoc boundary. Now, the other thing I need to do is our uploaded shapefile. Also, really easy. I'll just put in a feature reader. This is actually another way of reading data in, and I can actually attach that to this fail port here, which is the one we're taking when we're doing an uploaded file. Open up the feature reader, set it to read in a shapefile because we know it's going to be a shapefile. And I can give it the parameter from my file, like such. And click OK. That will be set up. And literally all I need to do for this one is go and attach this also to my reprojector. And I can even make this look a little neater because we've got a boundary coming from these files. I just need to make sure the coordinate systems align. Now that's our file sorted. The next thing that I want to do is to go ahead and add the clipper. The component of this is actually going to clip our boundaries, actually clip our satellite imagery to the boundary, whatever the boundary is. And that is intuitively named as a clipper. Go and add that there. Boundaries are the clipper. The satellite imagery is the candidate. And I can go ahead and just quickly set this up. The only thing I'm going to do is just quickly say no alpha bands. And then after that, I can mosaic this together. So mosaicing images together is basically taking lots of images and turning it into one image. And I don't want to spit out lots of images. I just want to spit out a single image. Don't need to change anything there. So now I've got a raster mosaicer as well. And once I'm happy with this, the very last thing that I would do is I would write this out to a particular format, and I'll make this one PNG. So a writer for a PNG is what we'll do. And I'll just go ahead and click OK. And click OK. Oh, no, I'll change it so it doesn't generate a world file and click OK. And I can go ahead and plug that in. And now we have a full workspace that's going to be published to FME Flow. And so let's do just that. Let's publish it to FME Flow. The very first thing that I need to do there is hit this publish button, which will bring up the wizard. I can specify where I want to publish it to, which I'll just do it under this demo folder. And I can specify which services I want to register it against, which I'll do data download and data streaming. Click the publish button. And it's going to go ahead and upload everything I need to. I'm just publishing the GTIFF files with it just to make it simple. So it's got the data there as it requires. And that's it. It's now published. I can jump over to FME Flow now, and we can have a look at setting this up. And just before we run it, though we could run it as it is now, if I wanted to, I could go ahead and jump into Run Workspace, find the demo workspace, and say specify a ad hoc boundary. Draw my boundary. I'm just going to draw one crazy boundary here, like such. Click confirm and run. And this will go ahead and run it. It might just take a little second just to read in those GTIFs and clip them. Hopefully shouldn't take too long though. And it's just going to load it directly into the browser because that's what the data streaming does. So it's clipped to my crazy boundary. But instead of just expecting people to come and hit this Run Workspace button, what I can also do is set up one of those workspace apps that we talked about. So I can call it Demo App, oops, without space. Call it Demo Clip App. And then I can just set it up with that same workspace and set it up as a data download service and go ahead and set up the parameters for it, which I'm happy with all of these. So once I'm happy with everything there, I can click OK. And the workspace app, if you don't actually set any unique sort of visualization options, if you don't set anything for how it looks, FME will actually do something for you and make it look nice still anyway. And here is now our demo clip app where I could say specify an uploaded file this time. And I could drop in a zip file of my shape files, go ahead and run that. And what I'll get in response is a file that I can then download. There we go. There's my link and downloaded. So, very quick example of how to put together a codeless web application that allows us to clip satellite imagery to either a ad hoc boundary drawn on a map or a uploaded file, in this case a shapefile. And with that, and the fact that I've been talking probably far too long by this point, I'm going to finish this discussion with a couple of final thoughts. And those are that the beauty of FME Form and FME Flow is that it is this codeless environment that you can very easily get started, start to design your workflows, take what you have and transform it into what you want. And as part of that really intuitive environment, it is so very easy to start building your codeless web applications in a matter of minutes and hours, not days and weeks. Thank you very much. I'll hand back over to the sales staff.